Okay, this is section 2.3, conditional statements. Identify the hypothesis and conclusion of each conditional statement. If today is Friday, then tomorrow is Saturday. The hypothesis of a conditional statement is the phrase immediately following the word if. The conclusion is the phrase immediately following the word then. So in this case, our hypothesis would be today is Friday, and our conclusion would be tomorrow is Saturday. Same idea for number 3. If two angles are supplementary, then the sum of the measures of the angles is 180. So once again, the hypothesis follows the word if. So two angles are supplementary. The conclusion follows the word then. The sum of the measures of the angles is 180. For number 5, write each statement in if-then form. 16-year-olds are eligible to drive. To write these statements in if-then form, identify the hypothesis and conclusion. The word if is not part of the hypothesis. The word then is not part of the conclusion. So we need to put if and then in there. So 16-year-olds. So if you are 16 years old, are eligible to drive. Then you are eligible to drive. So the hypothesis would be the first part, conclusion the second part, and then we just change the wording a little bit and put the words if and then in there. Number 7, the measure of an acute angle is between 0 and 90. So notice what we did here to change it to if-then form. If the angle is acute, then its measure is between 0 and 90. Okay, so for number 9, various kinds of precipitation form under different conditions. Write the 3 conditionals below in if-then form. Moisture in the air condenses and falls to form rain. So if moisture in the air condenses and falls, then it rains. The next one, supercooled moisture in cumulonimbus clouds forms hail. Supercooled moisture in cumulonimbus clouds forms hail. So if a cumulonimbus cloud has supercooled moisture, then hail forms. So we really had to change the wording around quite a bit there. So once again, supercooled moisture in cumulonimbus clouds forms hail. Changes to if a cumulonimbus cloud has supercooled moisture, then hail forms. And let's check out the last one here. When the temperature is freezing in all or most of the atmosphere, precipitation falls as snow. So if the temperature is freezing in all or most of the atmosphere, then precipitation falls as snow. All right, now we want to determine the truth value of each conditional statement. If true, explain your reasoning. If false, give a counterexample. So a counterexample is a single case that disproves, or a single case where the statement would be false, making the entire statement false. On number 11, if you live in Charlotte, then you live in North Carolina. Solution, the conditional is false. You could live in Charlotte, Michigan, or Charlotte, North Carolina. So just because you live in Charlotte does not mean that you have to live in Carolina, is basically what it's saying. And the counterexample is Charlotte, Michigan, or Charlotte, North Carolina. Number 13, if an animal is spotted, then it is a Dalmatian. So, once again, this is false. The animal could be a leopard. The hypothesis of the conditional is true. So, the animal is spotted. So you have a spotted animal. That would just be a true statement. But the conclusion is false. So just because there's a spotted animal that you see does not mean that it's going to be a Dalmatian. This counterexample shows that the conditional statement is false. So this is a false statement because of this counterexample. The animal could be a leopard. Or you could say any spotted animal. The animal could be a cow, would be another counterexample, proving that this is false. All right, 15, this is an interesting case here of how this works. So it says, if pigs can fly, then 2 plus 5 equals 7. Notice the solution here. The conditional statement, if pigs can fly, then 2 plus 5 equals 7 is true. The hypothesis is false, obviously, since pigs cannot fly. And here's what we need to remember. A conditional with a false hypothesis is always true. So this conditional statement is true. And this is just works from the laws of logic. So if you read a statement and the hypothesis is false, then the conditional statement altogether is a true statement. All right, in the next part, we want to write the converse, inverse, and contrapositive of each true conditional statement. Determine whether each related conditional is true or false. If a statement is false, find a counterexample. So on number 17, all whole numbers are integers. So the first thing that we want to do is put this in if-then form. So if a number is a whole number, then it is an integer. The next thing that we're going to do is write the converse of this statement. So it goes on to say, the converse is formed by exchanging the hypothesis and conclusion of the conditional. So we just flip-flop the two things after the if and after the then. So the converse would be, if a number is an integer, then it is a whole number. And we can see that this is false. So we need to give a counterexample. So basically, a counterexample, if a number is an integer, so we want to pick an integer such that it is not a whole number. And -3 would work, or we could say any negative number. -7. So -7 is still an integer, but -7 is not a whole number. The next part, we want the inverse. So the inverse is formed by negating both the hypothesis and conclusion of the conditional. So basically you put the word not in there, you negate it. So we take the original statement, if a number is a whole number, then it is an integer, and we negate both parts. So if a number is not a whole number, then it is not an integer. And once again, this is false. Our counterexample could be -3. So let's see why -3 works here. If a number is not a whole number, okay, -3 is not a whole number, then it is not an integer. Well, -3 is an integer. So proving that this is a false statement. Okay, once again, we can use another negative integer there. So let's say -10. So does it fulfill the first part, the hypothesis? -10 is a number that is not a whole number. Yes. Okay. Then it is not an integer. Well, hold on a second. -10 is an integer. So -10 is also our counterexample. The contrapositive is formed by negating both the hypothesis and the conclusion of the converse of the conditional. So basically what you do is you take the statement, you take the converse of it, so you switch the hypothesis and conclusion around, and then you negate that. So if a number is not an integer, then it is not a whole number. And this is true. So let's think about why this is true. If a number is not an integer, okay, not an integer, so let's say 1/2. 1/2 is not an integer. Then it is not a whole number. Right, so 1/2 is not a whole number, like 1 or 5, those are whole numbers. Okay, now we're back to identifying the hypothesis and conclusion of the conditional statement. So the hypothesis will follow the word if, the conclusion will follow the word then. So if you lead is the hypothesis, then I will follow is the conclusion. Number 21, if two angles are vertical, then they are congruent. So, hypothesis follows the word if, so two angles are vertical. Conclusion follows the word then, so they are congruent. And once again, doing the same thing here. If there is no struggle, there is no progress. So hypothesis, there is no struggle. Conclusion, there is no progress. Number 25, if a convex polygon has 5 sides, then it is a pentagon. So after the word if is our hypothesis. The convex polygon has 5 sides. After the word then is our conclusion. It is a pentagon. Next, we want to write each statement in if-then form. So everybody at the party received a gift. So we need to sneak if and then in there some way. We might need to rephrase some things a little bit here. So everybody at the party. So if you were at the party, received a gift. Okay, then you received a gift. So notice how this changes. Everybody at the party received a gift. Changes to if you were at the party, then you received a gift. Let's do the same thing for 29. The area of a circle is pi r squared. So we need to put some other words in there so that it'll make sense when we enter the words if and then. So if a figure is a circle, then the area is pi r squared. So the area of a circle is pi r squared. So if a figure is a circle, then the area is pi r squared. Number 31, a right angle measures 90 degrees. Change this to if-then form. So the hypothesis deals with the type of angle. The conclusion deals with what condition is true based off of this initial condition. So based off of the hypothesis, what will be true. So if it's a right angle, then it will be 90 degrees. So it would be set up like this. If an angle is right, then the angle measures 90 degrees. So changing it into if-then form. On 33, write the following statement in if-then form. At the Andy Warhol Museum in Pittsburgh, Pennsylvania, most of the collection is Andy Warhol's artwork. So, if the museum is the Andy Warhol Museum, then most of the collection is Andy Warhol's artwork. At the Andy Warhol Museum in Pittsburgh. So, if the museum is Andy Warhol Museum, most of the collection is Andy Warhol's artwork. So, then most of the collection is Andy Warhol's artwork. Determine the truth value of each conditional statement. If true, explain your reasoning. If false, give a counterexample. If a number is odd, then it is divisible by 5. This is false. 9 is an odd number, but not divisible by 5. The hypothesis of the conditional is true, but the conclusion is false. This counterexample shows that the conditional statement is false. So, we can pick another number. Let's say 13. So 13, does it fulfill the first part if a number is odd? So yes, 13 is odd. But then, does it make the second part false? Then it is divisible by 5. So is 13 divisible by 5? I don't think so. Therefore, 13 is another counterexample that would show that this is a false conditional statement. On this next one, a counterexample does not have to be in words. It can be a diagram. So if an angle is acute, then it has a measure of 45. So our counterexample would just be this diagram here, this angle. So would the hypothesis still be true if an angle is acute? So is this an acute angle less than 90? Sure it is. But then is the conclusion true? Then it has a measure of 45. This does not have a measure of 45. So the conclusion would be false. Therefore, the conditional statement is false. All right. Determine the truth value of each conditional statement. If true, explain your reasoning. If false, give a counterexample. If an angle's measure is 25, then the measure of the angle's complement is 65. So complement is an angle that with the other angle, they add up to 90. So they're complementary. So in our solution, the conditional statement, if an angle's measure is 25, then the measure of the angle's complement is 65 is true. When the hypothesis is true, the conditional is also true. Since an angle and its complement's sum is 90, so the conditional statement is true. So what does this all mean? It's just saying if an angle's measure is 25, so when that is true, 25, there's only one number that will have a sum of 90 with 25. So it says then the measure of the angle's complement is 65. Right. That's the only number that with 25 adds up to 90. So there's no counterexample to this. I couldn't say the complement could be 75 because 25 and 75 would not add up to 90. Number 41, if red paint and blue paint mixed together make white paint, then 3 minus 2 equals 0. So this is one of those weird ones. If red paint and blue paint mixed together make white paint, then 3 minus 2 equals 0 is true. It's a true conditional statement. And once again, here's why. The hypothesis is false. If you mix red and blue paint together, you're going to get purple paint. You're not going to get white paint. So this says the hypothesis is false since red and blue paint make green paint. And that's, there's a mistake right there. It should be make purple paint. Okay, a conditional with a false hypothesis is always true. So this conditional statement is true. Even though the second part is false right here, it doesn't matter. You can say anything for the conclusion when you have a false hypothesis. If you have a false hypothesis, the conditional statement is true by the laws of logic. If an animal is a bird, then it is an eagle. This would be a false conditional statement, so you could give many different counterexamples to this. We just want another type of bird other than an eagle. So we could say a parrot. So if an animal is a bird, yes, a parrot is a bird, then it is an eagle. No, it's a parrot. So you could say a cardinal if an animal is a bird. Yes, a cardinal is a bird. Then it is an eagle. No, it's a cardinal. So there's many different counterexamples showing that this conditional statement is false. Number 45, if two lines intersect, then they form right angles. This is false, and we could come up with a sketch to show that this is false. So our sketch here would be our counterexample. So do the two lines intersect? Is the hypothesis true? Yes, they do intersect. Then, do they form right angles? No, so the conclusion is false. Therefore, this would be a counterexample showing that this is a false conditional statement. Just because the lines intersect does not mean that they're going to intersect at right angles. For number 47, write the converse, inverse, and contrapositive of each true conditional statement. Determine whether each related conditional is true or false. If a statement is false, find a counterexample. So our conditional statement, if you live in Chicago, you live in Illinois. So the converse is formed by exchanging the hypothesis and conclusion of the conditional. So the converse would be, if you live in Illinois, then you live in Chicago. And the converse is false. A counterexample, you could live in Springfield. You could live in Bartonville. You could live in Peoria. So any other town other than Chicago. The inverse is formed by negating, so we're going to put the word not in there somehow, both the hypothesis and conclusion of the conditional. So the inverse would be, if you do not live in Chicago, then you do not live in Illinois, and the inverse is false. Once again, the counterexample could be Springfield, or it could be Canton, or it could be Morton. So if you do not live in Chicago, so let's take the example Morton. Morton is not Chicago. Then this says you do not live in Illinois. Well, just because you don't live in Chicago does not mean that you do not live in Illinois. The contrapositive is formed by negating both the hypothesis and conclusion of the converse. So we want to do both this time. We want to switch the hypothesis and conclusion around, and then we want to negate them. So if you do not live in Illinois, then you do not live in Chicago. And the contrapositive is true. So think about that. If you do not live in Illinois, then there's no way that you'll be living in Chicago because you don't live in Illinois. Number 49, if two angles have the same measure, then the angles are congruent. So the converse, we want to switch the hypothesis and conclusion around. If two angles are congruent, then they have the same measure, and that is true. By definition, congruent angles have the same measure, and if two angles are congruent, or if two angles have the same measure, then they are congruent. So it's biconditional. The inverse is formed by negating both the hypothesis and conclusion of the conditional. So the inverse, if two angles, we want to take the original, not the converse, but take the original statement and negate the hypothesis and conclusion. So if two angles do not have the same measure, then the angles are not congruent. So think about that. The inverse is true. If two angles do not have the same measure, so let's say one of them is 15 degrees, one of them is 20 degrees, then the angles are not congruent. 15 and 20 degree angles are not congruent. The contrapositive is formed by negating both the hypothesis and conclusion of the converse of the conditional. So we want to do both here, switch it around and negate. So if two angles are not congruent, then they do not have the same measure. The contrapositive is also true if two angles are not congruent. So two angles that are not congruent, then they will not have the same measure. On 51, first we need to convert this into an if-then form. So all congruent segments have the same length. So if segments are congruent, then they have the same length. Now we're ready to take the converse, so switch these two around. So if segments have the same length, then they are congruent, which is true. The definition of congruent segments are two segments that have the same length. For the inverse, we want to take the original statement and negate the hypothesis and the conclusion. So, if segments are not congruent, then they do not have the same length, and the inverse is also true. For the contrapositive, we want to do both. We want to switch it around and negate. So if segments do not have the same length, then they are not congruent. And the contrapositive is also true. Okay, now we want to write the statement indicated and determine the truth value. If a statement is false, give a counterexample. Animals with stripes are zebras. So first, we need to put this in if-then form. So that would be, if an animal has stripes, then it is a zebra. This is a false conditional statement. A counterexample could be a tiger, because a tiger is an animal that has stripes that is not a zebra. Or you could say a coral snake. A coral snake is an animal that has stripes, that is not a zebra. Now we're going to take the inverse. So we're going to negate the hypothesis and conclusion of the conditional. So if an animal does not have stripes, then it is not a zebra. And the inverse is true. Think about that. We have an animal, it does not have stripes. So if the animal does not have stripes, there's no way it can be a zebra, because zebras have stripes.